Hello everyone, welcome to a video presentation. Today we're going to be talking about passwords. Okay, we're going to be talking about ways that hackers might be able to utilize weak passwords to gain an advantage, and we'll also talk about how to make some strong passwords. So for this presentation I'm using OWASP's vulnerable web application package. So I've got a couple of web applications here that are vulnerable on purpose just as a sort of demonstration. The first page we're going to go over is this brute force sort of demonstration page on damn vulnerable web application. So we've got a login page here, yeah, and maybe the first thing to do if I was a hacker, I would maybe just guess a login. So maybe username, password, both admin, login, and that's worked. Okay, so I guess the first step to making a strong password is don't make it too guessable, because a hacker, maybe not even a hacker, right? Anyone, an opportunist could come along and just be like, oh, just guess, totally guess, maybe your last name and your date of birth or things like that, year of birth, something like that is easily guessable by anyone who can come across a login screen like this. So now that we know that the login screen works, maybe another thing I'll do is just test it anyway. So blah blah blah, and then say I don't know what the password is. I'm not going to guess admin. I'll guess something else. Login. Okay, so we get username, password not incorrect, but we also get this at the top. Okay, this PHP bit at the top. That's useful for us later on. So if I was a hacker now, maybe there's an opportunity to brute force this. Okay, so I can try a lot of different ones. You notice I'm not getting locked out. I can just try over and over again. All I get is a little error message. So how about on the main login page? Okay, we're going to try the same process. So we have a login page, blah blah blah. If we try foo and then bar, and then we get a login failed. So that's our failure condition message. Okay, we can look at some of the response stuff here. Eventually, there we go. So we can see the request payload. So that's how we're going to set out in Hydra. So if we get Hydra, blah, 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 here it is. So I've said here, Hydra, at this address, I want you to go through my username word list and my password word list. You're specifically looking for a HTTP post form here, and the here are the request parameters. So username from the users, password from the password, login equals login. That's just from down here. And then here's a failing condition at the end, login failed. So let's run this. So login admin, password admin, and then of course if we try it, that'll work. Yeah, nice, and then we're in. So that's how you could use a brute forcing tool such as Hydra to get into a website. Okay, we've gone over some ways where you can crack passwords on a website, but what if a hacker got access to your password some other way, maybe through a data leak or something like that? Most likely your passwords would be hashed, so it would look something like this. So these are all the passwords on my Linux system at the moment. You can see it's just all sort of jumbled up. You can't really tell what it says. These are hashes, and it's a way to sort of make it so that hackers and people who find your passwords, they can't find out what the original plain text version of that is. But I'm going to show you now there are ways around it, especially if they're weak passwords. Okay, there are a lot of tools going around, of course, for this as well. There's one that I like to use called John the Ripper, which comes with Kali packaged already for hackers to use, and it's just a hash cracking tool. Okay, and there's different methods you can use with this. You can use word lists, such as what we did with Hydra earlier. You can also just literally go through incrementally and look through every combination of the password until it finds a matching hash, compares it to the one that it's trying to crack, and if they're the same, then we know what the original plain text is for that. Okay, so there are different ways to go about doing this. So I've got some example hashes here. I've put them into a file hashes.txt, so we're going to chuck it into John the Ripper, and these should be quite weak ones, so they shouldn't take too long to crack. The whole basis around security and password security, it's all based around the fact that, or the idea that a hacker will not have enough time reasonably to be able to crack it. So for example, if your password is really strong, it might take 100 years for maybe a computer to be able to crack that password reasonably. Is a hacker gonna sit there for 100 years? No. So in that sense, it's secure. But then, of course, there's the concern about quantum computing and things like that. That might it might be a problem in the future when things are incredibly quick at calculations. So I've left this running for a little bit, and it's cracked most of the hashes. Okay, with some more time, I could have cracked all of them. But that's like I was talking about earlier. It's how long hackers can be bothered to sit there and wait for the hashes to crack. That's pretty much the level of security that you have. So I used a couple of different methods. Okay, you can see I've tried a couple of times with different things, and some of them have worked. So this one, I used a single cracking mode. It just focused on one of the hashes here, and you can see the password is Jane, so it's the same as the user. So it did it pretty quickly, right? That is a weak password, yeah. And when it's the same as the username, you can crack it that quickly. You can see it took 24 seconds, so really not that long. And then another one, Secret123. This was using a word list. This is why word lists are good. If it's a common sort of password like that, like password123, Secret123, word lists are a lot quicker than going through and properly brute forcing incrementally. So yeah, this also took a couple of seconds really to crack, maybe a minute or two to go through all of the possible things in the word list. It also depends on how big your word list is. It's going to take longer. And then I tried for a bit with the incremental one, but this probably would have taken a couple of hours. But you can see here it was going through all different numbers, and then going through some letters and things, and just properly brute forcing. So yeah, this is the ways that this is how easy it is, I suppose, for a hacker to find your password, even if it's hashed or encrypted. If it's a weak password, it's easily cracked. So I also wanted to talk about a little bit of there's mangling rules with tools like John and different password cracking tools, and these mangling rules, they automatically do different variants of the password. So things like an O is commonly replaced with a 0. So why don't I just replace, if your password was John, why don't I just replace the O with a 0 automatically, right? So all of these tools, they already automatically do things like maybe E usually it's replaced with a 3. Okay, numbers, groups of numbers, they're usually at the start or at the end of a password, aren't they? So these are easily guessable sort of patterns. Ones that you might want to think about avoiding when you create a strong password is stuff that can easily be sort of put into a pattern or a general group like this. Symbols at the start or end, numbers at the start or end, common numbers that are replaced with letters. And with this cracking process, hackers can use botnets to speed up this process. So this is just a group of lots of computers, and they all use their processing power together. So instead of maybe it taking a year to crack a reasonably good password with one sort of computer and all its computing power, you can just use maybe 100 computers, and then obviously that cuts the time down significantly. So there are always ways that hackers can get around the issue of waiting so long to crack passwords. But of course, the stronger your password is, the better. Like we saw in this example, the hashes that were used here, these is a default for Linux systems, so it's a very strong password. But if you have a weak, it's a very strong hash, but if you have a weak password, then that is sort of mitigated then, isn't it? The security is still weak if you have a weak password, so it's on it's your responsibility and the system's responsibility equally to make sure that you have sort of a secure solution. So this is why password managers are very useful, and they're becoming very relevant these days. That way you don't need to think of a password and maybe a password that is easily guessable. Okay, a password manager can do that for you, which is great because you don't need to remember a really long, annoying password. But the issue there is you need to think of a master password. So yeah, my advice for that would just be like what we talked about earlier. Don't put numbers at the end of the start. Make it something you can remember though. Okay, reasonably. Make it reasonably secure. Yeah. Okay. Well, thanks so much for listening, everyone. I hope this has been informative. Okay. Thanks.